Okay, hello everyone. It's a pleasure and welcome you all in our first webinar for the IEEE Censor Council Egypt chapter. And it's our honor to welcome Stoyan, Professor Stoyan. First, I'm going to introduce myself. I am Aida. I'm Dr. Aida Sabban, and I am the IEEE Censor Council Egypt Chapter Chair. And now moving to Professor Stoyan, which will he will give us a session about sensors in general and its type and categorization. So the mic is yours, Professor Stoyan, and please introduce yourself and then the presentation. Just one thing to add. This session is interactive. So I would urge you all to answer questions with Professor Stoyan. In the chat, you can put your questions and we will respond not at the end of the session, but immediately, as long as you put your question or comment. Feel free also to raise your hand if you want to talk, and we will give you the mic to comment on anything during the session itself. Enjoy. Thank you. Please, Professor.
Thank you, Aida. First, thank you very much for inviting me for this interactive seminar. Actually, before everything, I want to inform you that I prepared a few slides, but if I have to talk only myself, I can go through the slides for 15-20 minutes maximum. So the idea is not that I am giving a presentation, the idea is that we discuss things. So I would rely very much if anybody who would like to express his vision, his opinion, proposal, question whatsoever, just to do it. About myself, I have already a long career behind me. So actually, I retired in 2021 already. Before that, my career was split into two even parts. First, it was academic career until 1995 in the Technical University in Sofia, Bulgaria, where I come from originally. And then the Technical University in Delft, the Netherlands. And then in 2000, I switched from academia to industry. I joined a company called ASML in the Netherlands, nearby Eindhoven, until 2021. Actually, after I retired, I continued working for ASML, but not as an employee, but as a partner. And I also continued working part-time for the university in Delft in parallel with my work at ASML. So I share both academic and industry background. My field of industry is sensors. Initially, what I graduated was electrical measurement engineering, so more metrology measurement, but afterwards I switched more to sensors and sensor interface electronics. Regarding IEEE, I am right now live senior member starting this year. I've been mostly active in a few societies and lately in the Sensor Council. Societies like Instrumentation Measurement Society, of course, Industrial Electronics Society. And I have a small role in the Benelux IEEE section as industry liaison. With this, I prefer to switch to my slides. Let's share them. This should be the one. Okay. Switch to presentation mode. Is it okay now?
Yes, excellent.
Yes, sure.
The topic is related to sensor terminology. First, I want to say a few words why this topic, what triggered me to put some time, efforts to dig into this area of sensors. You know, in mankind or the human species evolution, it goes for millions of years, but there are some disruptions, big changes with huge impact on our progress. Right now, we're witnessing such disruptive change, so this is artificial intelligence. Of course, compared with our own human life, this is quite continuous process. It can take hundreds, even thousands of years, but with respect to evolution, this is very abrupt change. Another abrupt change with huge impact is the transition from non-verbal to verbal communication. This is the time when instead of just using our body to communicate, holding objects or producing some sounds, things like this, we started using words with certain meaning which everybody understands. This was a huge step forward. Now the question is, do we, after thousands of years using the verbal communication, do we use it, do we comprehend it the most efficient way? Of course, here there might be different answers. When it comes to science and technology, it appears that the communication is not always straightforward, especially in different science and technological fields. People have different understanding of the same term, or they use different terms for one and the same thing. When we add to this the use of acronyms and abbreviations, things become even more complicated. For me personally, it's very annoying when I want to understand a little bit more in a different field and somebody gives a presentation and he starts immediately using abbreviation acronyms, which the speaker believes everybody should know. And once you miss this, actually, you miss the whole story. So communication is very important. And when it comes to the field of sensors, unfortunately, we have this problem as well. Why this problem? Because first, sensor is a very, very multidisciplinary area. And different fields of science, as I said, they create their own kind of language, which makes communication among them easier. But on the other side, the price to pay is that people who are outside this area, for them, is difficult to understand. Also, the application of sensors, it's enormous. Sensors nowadays are everywhere. And the different applications, they create slowly their own way of expressing what they mean by sensors. And then the question is it okay? Can we live with this? Is it a problem at all? It appears that, and this is also my impression, for people, younger generation at younger age, they do not pay too much attention to this. They can live with this. But with the age, you start asking yourself, can we do it a little bit better? Can we use better this verbal communication? Could be vocal or could be also written. Can this improve the efficiency of what we're doing and how we exchange information? And this is the idea behind this discussion. As I said, I just prepared some information for you, but it's not something that I want to teach you or I want to convince you what I believe. It's more like sharing our opinion. So there are 4 points that I would like to discuss today. First, the motivation and background information about this topic related to sensor terminology and definitions. Then to discuss how we understand and define sensors. And then comes one interesting relatively new because it's already for more than 40 years available term called smart sensors. What is a smart sensor? And at the end, we'll talk a little bit how we classify sensors. By the way, if somebody has something else to share, to mention beyond these 4 topics, this also very much welcome. Now, about the motivation and background. First, my very early experience with sensors in the radar systems, this happened in 1997. Then the sensor terminology in my company, ASML, starting from the year 2000. The capricious use of the adjective smart with sensors and the confusion with sensor classifications. First, with the radar system. So a long time ago, almost 28 years ago, there's a company in the Netherlands which is producing radar systems. And once they announce an open day, which means that everybody is invited to visit the campus of this company and to look to their products. And what attracted my attention was that they're also going to show their sensors. So I went there, I started walking around the campus. There were signs directing me to the room where the sensors are. Finally, I found this room. But when I entered, what I saw are only a few big cupboards and nothing else. And they said, oh, that's the wrong place. Probably I'm in the wrong place. But somebody said, no, this is the right room. Here are our sensors. It appeared that what they call sensors are these big, huge cupboards. And when you look at what is a radar, it consists of a transmitter and receiver. So these are antennas, could be 2 separate antennas or one antenna doing both. And after the receiver, there is a processor to determine the properties of the object. And this is what they call a sensor, which was quite different from my understanding about what's a sensor. So yeah, that's interesting, but also very strange. Then in my company is a supplier, ASML is a supplier of lithographic machines called wafer steppers or wafer scanners, which expose certain pattern on the surface of a wafer. So what you see here on the slide is the wafer stage. On the top of it is the wafer. And this is a pretty simple process to explain what happens, but it's very, very complicated to execute when we start talking about nanometers, sub-nanometers, picometers, positioning, accuracy, and properties of the optical systems. And in such a machine, there are a lot of sensors. The latest platform has more than 2,000 sensors in one single machine of many different kinds. But in this machine, there are also metrology systems, which are measuring different parameters, so the position or the aberrations in the optical system. And somehow, I have no idea why, they start calling this metrology system also sensors. Maybe because it's just one word, sensor, maybe they like the word sensor. And it creates a lot of confusion because it's difficult to understand what do you mean, a real sensor or metrology system, which they also call sensor. This also causes and still is causing a lot of confusion in the company. Then, when we look what happens in IEEE, last year, actually, I was invited to contribute to the generation of a new standard, which was started actually in 2017. And the standard called IEEE Standard for Sensor Performance Parameter Definitions 2700. It was sponsored at the time by the MEMS Standard Development Committee of the Electronic Devices Society. And for some reason, that committee has been dissolved, and now they were trying to restore it. They sent me the material that was created at that time, 2017. And when I look at this table 1, sensor discussed in this standard and marked with yellow, see accelerometer, magnetometer, gyrometer, and so on. And below are sensors. So it looks like that at least these people, this group considers the meters, because it's all meters, sensors. And now the question is, but meter is a shorter name of measurement instrument, more like than a sensor. So it's also creating quite a big confusion. And then the question is, what sensors are doing? Very often you can hear you measure something with a sensor. So is the sensor a measurement instrument? And here is one definition of what is actually measurement. This is a process during which an unknown quantity is compared with a reference quantity of the same kind, and a value is assigned to the unknown quantity with associated uncertainty interval. This is the error, and the probability with which the real value is in the uncertainty interval. So three components of the result of measurement: a value, an error, and an interval. Are sensors doing this? I personally don't think so. Sensors are just sensing, right? They can be part of a measurement system, but they themselves are not measurement systems. So this is also a little bit confusing. And then finally, this term smart. The capricious use of the adjective smart with sensors. Well, smart or smartness, sometimes they believe smartness is a synonym of intelligence. These are qualities. These are not quantity. And we know from metrology that quality cannot be measured. You can measure only quantities. Smart, you can say, okay, you can compare it with a good or something that you want to appreciate, or you want to express your preference for something. But if you cannot measure it, then the question is, what is the value of this? And smart is taken from, let's say, living people. Yeah? People are smart, intelligent. Recently, the artificial intelligence became very, very popular. If you call a sensor smart sensor means that actually this is artificial intelligence, because smart is a synonym of intelligence. Then the question is, by using the term smart, does it provide more information for the sensor or more confusion? And it looks like that in many cases it's more confusing rather than a useful term, because different people understand different things about smartness of sensors. And all this aspects of sensor definition and terminology triggered me to take a closer look, actually. What is the common understanding, the common feeling about a sensor? And I come to the point that I would invite you, if you have your own opinion, what is a sensor, that you can share it now, if you don't mind. What do you believe should be the right, let's say, definition of a sensor? I cannot see myself if there are hands raised or any willingness to talk.
I will handle this if anyone wants to talk or write something in chat.
May I have an addition in this or contribution? For me, working on a smart solution as a smart city and smart agriculture, I think sensor is the apparatus or electronic system that provide the measure or sense of a physical parameter, such as you have demonstrated temperature, humidity, and even like a picture. That's from my point of view.
Okay. Thank you very much. So what I understood that the sensor is a system which is sensing.
Yes.
Okay. Other opinions?
May I?
Sure.
Yes, exactly as you said before, it's a bit confusing, but we can define sensors as a transducer which transduce some physical quantity into electrical signal at which we can measure, we can quantify, we can decide something else with a certain smart system to be a smart sensor based if there is an analog to digital conversion stages or so above this symbol sensor type. So this is my point of view regarding that.
Okay, great. Other opinions?
I think it's simply about mimicking human abilities in sensing other parameters like pressure, light, or anything.
Okay. I see quite similar opinion. The only thing is that I hear the sensor is sensing, but then sensing, sensor, yeah, they originate from one another. This does not provide too much information, right? I'm also reading a few lectures in a course here in Delft University. The course is Sensors and Actuators, and my lectures are at the end of the course. And I do an experiment with the students. They have followed almost the whole course. They have learned about different kinds of sensors and applications. And I ask them, well, if somebody meets you and you tell him that you follow this course and this person asks you what is a sensor, what would you say? So they adjust fresh information received from this course, and they have a huge problem to explain what's a sensor, which means that there's something wrong in this course because you should have at least a feeling. It's not necessary to know by heart a certain definition, but at least a feeling you can explain with more words, like many of you did right now about the sensor. It's okay. On the other side, long time ago, I think in a subject called logic, I remember, even it was in high school, they were teaching us how to create a definition. Maybe there are different ways, but the way I was taught was that you first have to, the object that you want to define, you have to assign it to a certain group of objects with similar properties. That's first step. And the second step is to define a property of your object which is different from the properties of all other objects in the same group. And now I'll show you some definitions about a sensor from different dictionaries and different sources. What you see first, that there is a kind of anonymous opinion that in the different definitions that a sensor is a device. Most of the definitions say a sensor is a device. In one case, says a sensor is an element, but mostly a device. Okay, then what this device is doing? This device responds to a physical stimulus. This device detects or measures a physical property. This device detects. This device records, is affected or produces. The last one says this device, module, machine, or subsystem that detects events, and so on and so on. So with respect to which group of things the sensor belongs, there is anonymity, I think is the right word. So most definitions say the sensor is a device, but when it comes what the sensor is doing, there's some diversity. Response, detects, records, affects, produces, and so on. A definition which I personally like is the last one. The sensor is a device that reacts to a stimulus and produces a useful signal related to it, mostly in the electrical domain. Okay, so then the question is, if the sensor belongs to the group of devices, then what is a device? And here are definitions about a device. This is a thing made or adapted for a particular purpose, Oxford languages, an object or machine that has been invented for a particular purpose, something devised or contrived, a machine or tool, a thing made for a particular purpose, an object or a piece of equipment, and so on. Basically, then device looks like to be something man-made for certain purpose. This is what I can conclude. Any opinions or about this kind of definitions or alternative definition? First, do you agree that we should assign sensors to the group of devices? Not systems or anything else, but should be something compact, should be something in one piece.
Yes, sure. It's a device. It's not a system.
Okay, great. And then what the sensor is doing? Is it responding? Is it detecting? Is it recording, affecting? Or as I said at the bottom, it just reacts to a kind of a stimulus.
I can see all those words are pretty much similar to each other, because the device, yes, it will detect some physical quantity. It will reflect or react to it with another electrical signal to be measured, and some other system will be smart with that sensor to be in touch with that sensor to decide something else, to do some actuator for some other important action or so.
Okay, very good, very good. There's only one, how do you call it, a small problem. If we say the sensor is a device which detects, then what the detector is doing? What the detector is doing? But I'll come to this later. Basically, any physical object reacts to its environment. If you have a piece of stone, for example, and the temperature changes, the stone will change its volume. It will expand. So in this sense, any physical object is a kind of a sensor because it reacts to, if you use the last definition, it reacts to a stimulus. The only difference is the stone is not man-made, it's existing. And now we say a sensor is a device, it's something man-made for certain purpose. Any other opinions? Okay, let's continue then. We understood what is a thing, also very broad definition about things. And now let's come to the IEEE sensor definitions. I looked in IEEE archives and I came to these definitions, the first two. The first one is in standard 1451.1 from 1999. There says sensor means a component providing a useful output in response to physical, chemical, or biological phenomena. And then, according to IEEE standard 1451.3 from 2003, the term sensor means a transducer that converts a physical, biological, or chemical parameter into an electrical signal. I would rather agree with these two definitions. only in the second one, the term sensor means a transducer. Then I look what is a transducer, what the definition for a transducer. A transducer is a device that converts variations in a physical quantity, such as pressure or brightness, into electrical signal, or vice versa. So actually, if we say here the sensor means transducer, and then we say the transducer is device. Why not directly saying the sensor is a device? It's simpler, I think. And there is another definition about a transducer in Wikipedia. A transducer is a device that converts energy from one form to another. Usually, a transducer converts a signal in one form of energy to a signal in another. Very often, people define sensor as an input transducer, because transducer generally converts signal from one energy domain to another. But sensors are typically used as the first transducer in a measurement or control system. So the first conversion of the quantity you want to control or measure into electrical signal, that's what they call it, input transducer. Again, if anybody wants to say something or disagree or whatever, please raise hand or just start talking. That I would appreciate this very much. Otherwise, we'll just continue. In the laboratory where I've been part-time for the last 20 plus years in the Delft University of Technology, long time ago, Professor Middelhoek defined 5 non-electrical domains: magnetic, chemical, radiant, mechanical, thermal, and input transducers or sensors. Actually, what they do, they react to stimulus in these domains and produce electrical signal, which somehow is related to the stimulus. Okay. Then we come to the detector. So these are the definitions for detectors I found in different dictionaries and sources. Again, the detector is a device, device or instrument, apparatus or device, piece of equipment, device or substance. That's very interesting, the right one, the last one. And what the detector is doing is detecting, discovering, detect, indicating, checking, find, indicates. And then it's interesting to say, okay, then what is the difference between a sensor and a detector then? In both cases, it's more or less, we agree that it's a device, and in both cases, it's detecting. Here, there's big diversity. It finds, it checks, indicates, discovers. But generally, what is the most important difference between a sensor and a detector?
Maybe the sensor is an input transducer, but the detector is at the receiver side.
The sensor is input transducer, a detector is, sorry.
Most of the time it's at the receiver side. It detects the modulated signal.
Okay, okay. Other opinion?
I have another definition, but from a communication point of view, because we have the difference between a detector and an estimator. The detector detects some discrete levels, while an estimator can quantify a continuous in a continuous range. So it's a bit different.
Okay, that's great. Yeah, go on. I have to say that I also agree with this. Basically, when we say we detect presence. So presence or absence, yes or no. Yeah? That's more how we use this term detecting and detector. While a sensor produces a signal which is related to the stimulus. There is some function. So it could have many levels. So it could be digitized output. It could be continuous analog, but it's not just one bit, 0, 1. It's actually a certain range in which the sensor can produce a signal corresponding to the stimulus. This is my my personal interpretation. Although in practice they mix the term sensor and detector. Very often they use the term photodetector. Yeah? But this actually could be sensor. It could be not something which detects light or no light. It can measure orders of magnitude range of light intensity, but they call it photodetector. Yeah? That's traditionally. So this is also a little bit confusing. If no other comments, opinions, then continue to the smartness of the sensors. Then the question is, what is a smart sensor? Again, have somebody of you use this term for something, and what is the interpretation for a smart sensor? Okay.
I can participate in that. So maybe we have like it has some adaptation whether to detect in a certain range or another. Maybe it can be also connected to other sensors, and there can be some fusion of the sensor readings of several sensors. So the smart thing here is can be different things. But what I mentioned is something that can be said as smart. But of course, there is a wide spectrum of what is smart.
Okay.
I can contribute also in this.
Please.
I believe the word smart may be related to the sensor which is going to detect some physical parameter, and then maybe act on this in a predefined actions. So this is why it's called smart, maybe.
Okay. Other opinions?
Yes, please. Yeah, I agree with Dr. Aida. And actually, now we elevated the sensor from just a device up to a system level.
Yes.
Because now the sensor converts some non-physical, non-electrical quantity, any physical quantity, into electrical quantity, but not that only step. It has another reaction now, which will react based on the value that is sensed by that sensor. It will do something else. It will take an action. This means that it will be something like a system on a chip, or some other system which will take an action based on the sensing step.
Okay, great. So looks like we can... Okay, go on.
I believe the word smart here indicates the capabilities of accessing a network, for the sensor to access the network, either to send or receive data from this specified network that it uses, not only act on it, but also access it remotely with that. Yeah.
Okay. Other opinions?
Maybe smart also is related to having multiple sensors working together, like in IMUs, when we have the 3 sensors working together to get 9 degrees of freedom for activity capturing and sending the data to a remote access point or a laptop.
Okay. it looks like that we come to one common understanding that a smart sensor should do something more than a normal sensor is doing. Should have some additional functions or whatsoever. So should be more complicated, should provide more information maybe. Okay. Now, I shall go through a few smart sensor definitions in 3 slides. First, outside IEEE and then internal IEEE. So the first definition here, smart is frequently used as a prefix to mean new and improved for technology and even consumer type products. The term smart sensor has been used for about 4 decades now. The first time mentioned by this author, Giacchino, in Sensors and Actuators, 1986. Earning the smart prefix meant the sensor performed a function that could not be previously performed or was not previously economically viable. Okay, this definition I found in this source. Then intelligence. So here, smart and intelligent, some people say these are synonyms, other people say yes, but not quite. So there is some different flavors in smart and intelligent. But let's, for the purpose of this discussion, we assume that smart and intelligent are synonyms. So intelligent sensor is a sensor system that can adjust the internal performance of the system to optimize the ability to obtain external data. So then again, here, intelligent sensor is not a device. Intelligent sensor is a sensor system. That's basically what says this definition. Okay, the next one, a sensor that conditions the signals before transmitting them to the control network. Smart sensors filter out unwanted noise and compensate for errors before sending the data. Some sensors can be custom programmed to produce alerts on their own when critical limits are reached. Again, a sensor which does more than just reacting to a stimulus can be considered in the group of smart sensors. Okay, next. Smart sensors include an embedded digital motion processor, whereas base sensors don't include one. There are all kinds of smart sensors, but the most commonly used ones are level sensors, electrical current sensors, and so on and so on and so on. Smart sensors are synonymous with Industry 4.0. Okay, obviously you guess from which corner this definition of smart sensor comes.
Why especially is that the embedded digital motion processor specifically? It's strange for me.
Very strange indeed, I fully agree. But here, what is specific for this definition, it says the smartness of the sensor is not defined by what it does, but what it contains. So here, if you have a sensor which has embedded digital motion processor, it's a smart sensor. Maybe this digital motion processor is not functioning at all, but when it's present in the sensor, then this is a smart sensor. That's more or less how I read it. Other comments? Okay, then continue with the next definition. Smart sensors are devices that take information from a physical environment and use embedded microprocessors and wireless communication to monitor, examine, and maintain various systems. They have the ability to collect environmental data more accurately with less erroneous noise. So this definition contains both. So smart sensor can do more than normal sensor, but it also should contain something, embedded microprocessors, for example. These definitions are taken from this source in case you want to take a closer look. And the last one, which is from Wikipedia, intelligent sensor. An intelligent sensor is a sensor that takes some predefined action when it senses the appropriate input, light, heat, and so on. Because the tasks are performed by microprocessors, any gadget which mixes a sensor and a microprocessor is usually called an intelligent sensor. To qualify as an intelligent sensor, the sensor and processor must be part of the same physical unit. A sensor whose only function is to detect and send an unprocessed signal to an external system which performs some action is not considered intelligent. And elements of intelligent sensors, below you see a list: primary sensing element, excitation control, amplification, analog filtering, data conversion, compensation, digital information processing, digital communication processing. I don't know what feeling you get, but looks like there are quite wide range of interpretation about the smartness of the sensor. And all of these definitions, interpretations, lead to, let's say, extending the function of the sensor. In the definition of a sensor, say, okay, it reacts to a stimulus and produces signal corresponding to it, most often in electrical domain. So this is a sensor. And when we start adding to it different functions, which do not typically belong to the sensor, then we say, okay, this is a smart sensor. I personally don't think that this is ideally accurate. And the problem is not with this, but the problem is that if we want to categorize smart sensors in a way to say which sensor is more smart than the other, and because smartness is a quality, it's not possible to compare. So it's a personal feeling. Yeah? It's something you like or don't like. And to get out around this problem, we start actually adding our own understanding what is smartness. Somebody says it should have independent logic. Somebody says it should have a processor. Somebody else says it should have some additional function. But the analog filtering, the amplification, is not typical function for a sensor. This is the electronic interface that is doing this. And then people say, yeah, but if we have integrated sensor, so in the same die, piece of silicon, is the sensing element and the amplification and analog filtering, we say, oh, this is just one device and it has all these qualities, then it's a smart sensor. So when it's integrated sensor, it's smart sensor. We can live with this, that's my opinion, but this diversity of definition and understanding of what a smart sensor does not add, let's say, additional information about the sensor. And I had a long discussion with two professors, I mean a few years, who come from the metrology world, before I invited them to write a chapter in a book. Let's see, no, it's not here, especially explaining what is the origin of smartness. And their opinion is that the term smart comes from the commercial side. It's more like, say, okay, I produce and I sell sensors, and if I want to advertise my sensor, I call it smart sensor. Smart means good in this case, right? You don't have to quantify it, you don't have to measure it, you say that's a good sensor. This attracts attention for the potential customer to take a closer look and read actually what this sensor can do. But the fact that you call it smart does not give a lot of additional information unless there is one single definition about smart sensor. And then we both came to the conclusion that if we have to talk about smartness of the sensor, it would be better not to add additional functions which belong to different converters, but to look at the sensor itself. So it reacts to a stimulus. The smartness, for example, would come from the fact that, so the ideal sensor is the one which reacts only to one stimulus, to nothing else. Only, for example, reacts only to temperature, no pressure, no humidity, no mechanical intervention whatsoever. So then it means that it does not absorb any external noise, right? It reacts only to one single sensor. That's very smart. And that belongs to the fundamental property of the sensor. Then another property of the sensor would be that it maintains the conversion between what is the stimulus and the output signal the same, stable, in any kind of environmental conditions. That's also smart, and that also belongs to the sensor itself. So basically, if the sensor is more stable, more reliable, more robust, and can withstand to different interventions or changes in the environment, and still does its job, yeah, that's pretty smart, right? So that's the other, let's say, understanding. Not to mix what sensor is doing, if we have a definition for a sensor, and not other following functional blocks after the sensor are doing. But okay, this is something that I'm sure many people will disagree. So just leave it like this. Any comments, Dylan? Okay, let's go on. Here's a list of IEEE standards which are related to smart transducer interfaces for sensors. So here, this is a very smart approach. The approach itself is smart because they don't talk about the sensor itself, but they talk about the transducer interface for sensors. And these are two different things. So one thing is the sensor, and the other thing is how the information generated by the sensor is transmitted and how the sensor is defined. For example, in this, these are all 1451 standards, 0.01 and so on. This, for example, 1451.3 from 2003 says the title of this standard, Digital Communication and Transducer Electronic Data Sheet, TEDS, format for distributed multi-drop systems. So this standard, this particular standard is that says, okay, the sensor, although it may produce an analog output signal, it should contain in itself a data sheet. A data sheet with its parameters, even who is the supplier, part number, all this information, which can be read digitally, by the way. I don't know how successful this sensor was. It was 2003, there were some sensors on the market which contained these TEDs, but as far as I know, without pretending that my information is very reliable, there are not so many, at least the sensors I've been looking for on the market contain this test. But anyway, here the story is not about the sensor itself, but about the interface and the smart interface, not the sensor itself. Okay. Now, and then finally, how to deal with the smart sensor definitions. This is information which I took from different sources, but the first one, the need to harmonize the terminology in the field of sensors, including those with elements of artificial intelligence. It is necessary to find a criterion for determining the level of intelligence of this device, just to measure intelligence, basically, which could be applied for forming a corresponding terminology group. So basically, this says we cannot measure quality. To make sense of, for example, this adjective smart, we have to convert it from quality to quantity. And then at a quantity, then we can measure it, and we can divide different level of smartness and so on. And the source is smart sensors and MEMS. In this chapter, I mentioned to you just in the previous slide. And because it's here, they talk about artificial intelligence. So sensor is something artificial, it's not a living organism. And when it's smart or it's intelligent, then basically we're talking about artificial intelligence at the time when artificial intelligence was not so popular already. And here's the definition for artificial intelligence. This is a field of research in computer science that develops and studies methods and software that enable machines. So artificial intelligence is a machine which perceives their environment and use learning and intelligence to make actions that maximize their chance of achieving defined goals. Well, that's a little bit too much for the sensors we're talking about. Okay, with respect to timing, I'm already 1 minute over time, I think, but very quickly, how do we classify sensors? That's also very interesting. Now people talk about capacitive, resistive, pressure, temperature, whatever, different sensors. But this sometimes creates confusion. And why? Because if I say pressure sensor and capacitive sensor, it could be one and the same thing. Because when I say a pressure sensor, it means what the sensor is sensing. It's pressure. So this is the physical quantity. This is the stimulus. When I say capacitive sensor, it means how we interpret this sensor in electrical circuit as a capacitance, right? And it could be one and the same. And that's why I try to define 3 criteria based on which we can classify sensors. Based on what the sensor is reacting to, could be temperature, humidity, pressure, light, acceleration, whatsoever. But with respect to electrical domain, how we interpret the sensor as components in a circuit, it could be capacitance, inductance, resistance, could be current source, could be voltage source, and so on. By the way, one of the same sensing element put in different working conditions could be interpreted as capacitance, inductance, or even resistance. So it depends also very much how do we use the sensor. Also, with respect to technology, there are MEMS-based sensors, integrated sensors, and so on, the way they are produced. And then their operation in electrical circuit, that's maybe not that popular, but at least in the past it was used, generating and modulating. Generating sensors, for example, a photodiode, like a solar cell, for example. The energy from the incidence light is converted into electrical energy, so it generates actually the signal. It doesn't need external supply. Well, modulating sensors, they actually need some biasing, voltage or current, and depending on the stimulus, they modulate the current or the voltage. Okay, any comments related to this last part about the classification? Do you think there are other criteria for classifying sensors? Okay, if not, I think I came to the end of my slides. Now we are over time, but if you have some general comments, including, do you think it was useful to have this kind of discussion? Do you think something should be done in this area, the sensor definitions?
I have a comment here, if you allow me.
Sure.
Could you please elaborate on the last slide, because I'm coming from communications background, so I'm not into sensors and electronics deeply. But I find this interesting to classify the sensors based on application, temperature, humidity, pressure, and so on. And what's the difference between capacitive, inductive, resistive, and so on? If you may elaborate more on that.
What is the difference in the electrical interpretation of the sensor? That's
Yeah.
well, okay. Let's take a capacitive sensor. So this sensor is sensing something. Could be acceleration, could be pressure, or anything else. Could be even humidity. And then it converts this stimulus into capacitance. So we have then, in order to extract information about the stimulus, let's say pressure, we have to measure the capacitance. So what the sensor is doing, it is just reacting to pressure and is changing its capacitance as an output signal. Now, by the way, capacitance is not electrical signal. So to have electrical signal, we have to provide some biasing. For example, could be AC voltage and to measure the AC current, or AC current to measure the AC voltage, because direct DC current cannot run through capacitance, right? That's the definition for capacitance. So to measure the value of the capacitance, we have to provide some stimulus. So capacitive pressure sensor, so capacitive pressure sensor is of modulating type, right? And if it's produced using MEMS technology, very often, for example, accelerometer pressure sensors are based on the capacitive principle, and they use MEMS technology. So then we can define it, this particular sensor, pressure sensor, capacitive principle, MEMS-based technology, and it is of modulating type. Now, but ideal capacitance, ideal inductance does not exist in reality. You build a capacitor by having two plates in parallel to one another, right? Depending on the area, the distance between the plates, and the electric constant of the media between the two plates provides the value of the capacitance. But there are also losses, inevitably losses. And when you go to very high frequencies, actually you look at this capacitance as an impedance. So you look at it as a capacitance in parallel with which there's a resistance representing the losses. And if you go to even higher frequency, then you look at it, so the resistance starts dominating the capacitance. So it becomes more like a resistive component than a capacitive. And if you have parasitic inductance, there's always some wiring. Okay? There are two wires connecting to each plate of the capacitor. When you go to very high frequencies, with increasing the frequencies, the reactance associated with inductance becomes dominating the capacitor. So at low frequencies, what you see more is the capacitance of this complex structure. High frequency, you see the inductance. Because one is increasing its value with the frequency that is reducing its value. That's why what I say, it depending how you put it. When you want to use the capacitive component of this complex impedance, which we interpret the sensor in electrical circuit, you have to put it in the right working conditions to use the right frequency and so on and so on.
Clear. Thank you so much.
Provided the answer you were looking for. Any other comments? Well, if not, thank you very much for your attendance. I hope it was not too much boring to you and was a little bit of use. And if you want to, I think the slides will be sent to Aida, and if you want to have them, of course, you will have them.
Okay. Thank you very much, Professor Stoyan. Thank you for your time and effort. And the presentation, of course, and hope it was beneficial discussion and interactive between all attendees, and looking forward to further webinars in the future soon. Thank you. Thank you very much. Okay. Bye-bye. Bye.
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 Thank you. Thank you very much.
Thank you.
Thank you.
Bye.